Assalamu alaikum. Kirchhoff's first law. This is a very important part in physics. Now let us study Kirchhoff's first law or Kirchhoff's first law. We know that charge is a physical property of a particle. Charge carriers are electrons. So we have here principle of conservation of a charge. The total amount of a charge in an isolated system remains the same. It means the number of electrons entering a junction. What do you mean by junction?
This is not a junction. This point is not a junction. It is just wire up to another wire. This is called junction. It is the point of connection of the wires.
Junction is the point of connection of the wires in the circuit. So the number of electrons entering a junction equals the same number of electrons leaving that junction. We don't have half electron or 1.5 electron. So the total charge is conserved. So the total charge before junction must equal the total charge after junction. So the sum of Q in equals the sum of Q out. Since the current is the rate of charge flow, so we can say Kirchhoff's first law states that the sum of currents entering a junction in a circuit is equal to the sum of currents leaving it. How can we decide the current in or out? Depends on the arrow. For example, if we look at this, I1 is in, so this is called junction. So this point here, this point is called junction. So the sum of current in I1 is in, the arrow goes in, I5 is in, I4 is in, I2 is out, I3 is out. So for this example, we can say the sum of currents in, it means I1 plus I5 plus I4, that are the sum of currents entering that junction, equals the sum of currents leaving that junction. So it's equal to I2 plus I3. Kirchhoff's first law, sometimes called law of current or conservation law or junction law. So the charge is conserved in Kirchhoff's first law. Remember this, in any circuit the charge is conserved.
Now we apply Kirchhoff's first law. This is a junction, so this is the current in, and that are the currents out through the two resistors. So we connect the circuit as shown. So we have 3 ammeters. This is ammeter for current in. We can say this is I1, and this is I2, and this is I3. I1 related to resistors are 1, and I2 resistor are 2, and connected to the power supply. Now we're starting to get the measurement. So this is I1, it is 3.8 ampere, and this is I2, it is 2.5 ampere, and I3, it's 1.4 ampere. So I1, the current in, is 3.8 ampere, I2 out, I3 out, I2 equals 2.5 ampere, and I3 1.4 ampere. Now we check I2 plus I3. I2 plus I3, it's 3.9 ampere. I1 is 3.8 ampere. So approximately I1 equals I2 plus I3. It means we apply Kirchhoff's first law. The sum of current flowing into the junction equals the sum of currents leaving that junction in the circuit.
Let us see that question. Determine the current flowing between A and B and the current Ix. Let us we see that one. This is junction A. So we're starting at, we say at junction A. The current in is 0.5 ampere. The current out is 0.3 ampere. So the current in is greater than the current out. So at A, B must be current out, not in, because the current in must be equal the sum of currents out. So the direction of the current through AB, it's out. So let this is denoted by I. So at junction A, the current in is 0.5 equal the currents out 0.3 plus I. From this equation, we can get I shift 0.3 to the other side. So I equals 0.5 minus 0.3 equals 0.2 ampere. So this is the current between A and B. What about IX? Now we talk about another junction. At junction B, here, the current in is I, which is 0.2. So we write 0.2. The current out is 0.1 plus IX, the required. From this, we can get IX if you shift 0.1 to the other side. So IX equals 0.2 minus 0.1 equals 0.1 ampere. Now, let us study resistors in parallel, because we use Kirchhoff's first law to deduce the formula of resistors in parallel. That are important question. Drive using Kirchhoff's laws. Now we use Kirchhoff's first law. The formula or the formulae for the combined resistance of two or more resistors in parallel. Now in that circuit we have three resistors connected in parallel. How can we decide parallel or series? It depends on the currents. If the current is the same, so it's series. If the current is different, so the current is split into different current, so this is parallel. Let us study this circuit. Now here, so we have here the current, conventional current. Let the conventional current denoted by I from the battery, and this is junction. At this junction, the current will be distributed into I1, I2, and I3. So this is a junction A and this is junction B. Of course, the current leaving at B is the same, so it will be the same current. Now, we're starting the solution at that. From Kirchhoff's first law, we use Kirchhoff's first law. At junction A, the sum of current in, it's I, equals the sum of currents out, I1 plus I2 plus I3. We have a relation between the voltage, potential difference, and the resistance. So the relation is that V equals I times R. Because the resistors are connected in parallel, so the potential difference between the points A and B is the same. So it is the same voltage of the battery, because they are parallel connection. So what about I? I equals V over R. For I total, I coming from the battery, it is V over R total. R total is the combined resistance, equals I1. I1 is the voltage through R1. So the voltage is V, the same voltage. So I1 equals V over R1. Plus I2, it is V over R2. Plus I3, which is V over R3. The same voltage, because they are parallel, so we cancel V with V with V with V, but replace them by 1. So the formula at the end, 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. Let us we take example about this. Let R1 is 5 ohms, R2 for example 3 ohms, R3 10 ohms. What is the R total, the equivalent resistance? So for this question we write here 1 over R total equals 1 over 5 plus 1 over 3 plus 1 over 10. We use the calculator to get the answer as a fraction. The answer is 19 over 30. This is not R total, it's 1 over R total. So how can we get R total from this? We flip both sides. So R total over 1, it means R total equals 30 over 19. 30 over 19. So 1 divided by the answer, 30 over 19, it becomes approximately 1.6 ohms. What do you notice about R total? In resistors in parallel, R total is smaller than the smallest resistance. The smallest resistance is 3 ohm. R total is 1.6 ohm. So if we need to minimize the resistance of many resistors, we connect them in parallel. We have a special case if they are just 2 resistors in parallel. So this is a special case. So special case, if there are 2 resistors in parallel, so we can say this is the formula to be easy. R total equals R1 times R2 over R1 plus R2. So this is a special case if there are 2 resistors in parallel.
Resistors in parallel. First, we measure the resistance of each one by using the multimeter. So we use the multimeter instrument to measure the resistance of each one. This is the first one. So the first one is 10.2 ohms. The second one, 14 ohms. The third one, 23.2 ohms. R total, by using the formula 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over 3, it will be 4.7 ohm. Now we need to measure the total resistance by using the multimeter. So we connect them in parallel. Now we connect the 3 resistors in parallel. So this side with this side. So we use the multimeter to find the total resistance in parallel. So R total by using the multimeter, it is 5 ohm. Why it is not 4.7 ohm? Because we use many wires and the wires have own resistance.
Let us we see this question. Calculate the current. Now read the question with me. Calculate the current in 20 ohm resistors shown in the circuit. Now in this circuit, the potential difference is 10 volt. The resistors are connected in parallel. So each resistor has the same voltage, which is 10 volt. So related to this, it's 10 volt because they are series, they are parallel. So also this is 10 volt. What do we need? We need the current through 20 ohm resistor. Now, what is the relation? The relation is that Ohm's law. V equals I times R. We need the current. So part I, the current through 20 ohm resistor equals the voltage divided by the resistance. So the voltage is 10 and the resistance is 20. 10 divided by 20 is 0.5 ampere. So this is the current through 20 ohm. Now, we need determine the current drawn from the battery. So we need I total. To get I total, we need to calculate R total. They are parallel connection. So R total, we say 1 over R total equals 1 over R1, 1 over 20, plus 1 over R2, 1 over 40, plus 1 over R3, 1 over 50. Now we use the calculator to get the value. So the answer is 19 over 200. Take care, this is not our total. How can we get our total? We flip both sides because it's 1 over R total. So R total in that circuit equals 200 over 19 ohms. We need I total. Now, what is I total? I total equals V total over R total. V total, it is the voltage from the battery, which is 10. R total, it's 200 over 19. So we write 10 divided by the answer, which is 19 over 20. So it is equal 0.95 ampere. I hope you understand this lesson. Thank you.